In this video, we're going to walk through how to actually perform the quantitative transformations on our skewed distributions. So it might be helpful to go back and look at the distributions of the original variables so we can confirm their skewness and then make those corrections. So to start, I'm going to add a new worksheet to the end of my last relationship testing lab worksheet so we can perform these quantitative transformations. So right now I'm clicked in that last testing worksheet. I'm going to click the plus sign to add a new worksheet, and then we're going to rename that worksheet Quant Transform Lab. Okay, now to begin, we need to copy over the variables that we want to transform. So we're going to go to our lab cleaned data, and we're just going to take our original above ground living area variable and our sale price variable. Okay, so I'm going to always take house ID with me just in case I do alter the data in any way. I'm going to take that above ground living area variable and I'm going to take that sale price variable, just focusing on the original variables we were given. Okay, copy those variables and we'll paste them in our new worksheet. So we're going to end up performing two transformations on each of these variables. So I'm going to add two blank columns after living area above ground, and then I'll produce two blank columns after sale price. So since I want two blank columns after living area, I'm going to highlight these two columns to the right of living area and then press my insert tab. So there's my two columns. And then because I already have two blank columns after sale price, if I want them to be formatted similarly, I can just copy this column. And then when I come over here to paste, I'm just going to paste the formatting here and then just the formatting here. So we get two columns that look similar to the original. Okay, now to start, it might be helpful to, again, just go back and reflect on those original distributions and see their skewedness, compare those measures of center so we can confirm that those are the distributions that we were seeing. So to begin, I'm going to just click on my living area variable, and then we'll insert just a simple histogram to look at that picture. And we can title this Living Area Original so that when we start adding more of these visualizations, we know which one corresponds to which variable. Okay, so we can visually see that this distribution is skewed to the right. It doesn't appear to be like super significant. We did already do some cleaning up of the outliers to address the really extreme ones. But overall, we do see this distribution skewed to the right. Okay, we can do the same thing with living area. With sale price. And then again, we can see this distribution is also skewed to the right by a bit of a larger degree. All right, so there's our two original distributions. We know they're skewed. We know that some of the assumptions of our relationship test that we perform and the assumptions of this final model that we were going to build are that the underlying distributions of the variables are normally distributed. That's one way of saying that they're unimodal and symmetric without significant tails or significant outliers. So one way that we can correct the skewness of these distributions without biasing the data is through data transformation. So when we have distributions that are skewed to the right, we're going to use root transformations. That's where we take every value of the original variable and take either the square root or the cube root. And we do that by raising it to the power of 1/2 for square root transformations and to the power of 1/3 for cube root transformations. And ultimately what we're going to see visually is these distributions become more symmetric, but we'll also assess them from a quantitative perspective by comparing their measures of center, the mean and the median. So to start with these transformations, I'm going to go up here and I'm going to add some titles to these. So this is going to be living area. I'm just going to do SQRT for square root and living area CBRT for cube root. Now, if we had distributions that were skewed to the left, we would not want to use our root transformations. We would instead use power transformations, where we raise everything to the power of 2 or to the power of 3, depending on the degree of skewness. We're going to do both and just examine the effects. Okay, same thing for sale price. Since this distribution is skewed to the right, we're going to perform a square root transformation and a cube root transformation. Now, these transformations are relatively easy. It's just a simple formula. And as long as we're performing the same transformation to every value, we're not actually biasing the data. We're just transforming it mathematically to conform to the model assumptions. So we're going to use the equal sign. We're going to select that original variable, and we're going to raise it using our little caret that should be above your numeric 6 key. And then I want to open my parentheses before I put that 1/2. Okay, if I don't put that exponent in parentheses, it's going to raise the value to 1, and then it's going to divide the whole thing by 2. So one important component of this is you have to make sure that this 1/2 and the 1/3 are both wrapped in parentheses so that it treats it as 1/2. Alternatively, you could put 0.5 instead of 1/2, and then you don't have to worry about putting the parentheses. But if you want to keep it similar to mine, then make sure that you do it this way. Okay, and then for the cube root, we are again going to select that original variable, and we're going to raise it to the power of 1/3. Okay, so after we get those formulas working correctly, we can highlight both of those cells where we have those new formulas, come to the bottom right corner where we have that little green square, and double click, and that will fill our formula down to the bottom. If we want to reduce the number of decimal places, because this is a lot to look at, your cells are already highlighted, so you'll just come up here and reduce it down to 1, 2 decimal places, whatever feels good for you. Okay, now one thing that we can do, so we can confirm this is raised to the power of 1/2, we can confirm this is raised to the power of 1/3. So we're going to be performing the same transformations over here for our sale price variable. So we can just copy these formulas, Control C, and then when we come over here to paste, instead of Control V to paste, we're going to right click and select this paste formulas. Okay, then when we click on it, we can see, oh, it's raising E2 to the power of 1/2, which is for sale price, and this one is raising E2 to the power of 1/3. Alternatively, you could just redo the formulas. Essentially, we just want to make sure that we're raising sale price to the power of 1/2 and then sale price to the power of 1/3. After we get those transformations completed, we'll fill the formula, and then we can reduce the number of decimal places. Okay, so we have our transformations. Now let's create some histograms to see if visually it appears that the distribution is becoming more symmetric. So I'm going to click on column C. I'll go to my Insert tab. We've created lots of histograms in this class, so this process should be pretty familiar. And then paste that over to the side. Okay, and then we'll do it again for this living area, and then we'll go assess these distributions. Okay. So we have these distributions. This is our living area square root. Just going to give it a simple title. We don't have to overly format these. They're really just for your assessment purposes, but also I need to know which graph is associated with which transformation. So make sure you do give them these kind of simple titles so we can distinguish which one we're looking at. Okay, when we look at this, these distributions, we can see this is skewed to the right, slightly, not super significant, but it is skewed to the right. When we perform our square root transformation, we see that distribution becoming more symmetric. We see the center of that distribution moving more towards the center of the graph. And we perform the cube root transformation. It looks very similar to the square root. The point is they appear to be improving in their skewness with these transformations. Now we can do the same thing for sale price. Okay, that's the square root. And then the cube root. Okay. Make these the same size for comparison's sake. Oops. Okay. This is sale price square root. And this is sale price cube root. So the distributions with sale price. So this was more significantly skewed to the right. We can see with the square root transformation, it is starting to push the bulk of the data towards the center of the distribution, and then it's shifting a little bit more here. So while this doesn't look perfectly symmetric with the histogram, we do see the improvements, but this is as far as we're going to go with our transformations. We can also create side-by-side box plots so that we can see if it is kind of taking in those outlier values that are creating that skewness. So if we start with our original living area variable, okay, so this is living area original. Okay, I'm going to pull these down so that I have a place for these box plots. Okay, we see those outliers on the top end of the distribution. We did take care of the most extreme ones, but we left the ones that were closer. Now we can perform or create that box plot for the square root transformation. Okay, now one thing that I do notice here, let me just stretch this out in the space, is that the number of outliers appear to be decreasing, and the overall box plot, the box and whisker plot, appears to be more evenly distributed from the minimum to the maximum. So we can see it is kind of reeling in those extreme outliers, or maybe not extreme outliers, but those outliers that are still creating the skew in the distribution. Now, if we recreate one more, we'll probably even see more of those outliers that tend to disappear. Okay, again, I'll adjust this axis so we're evenly distributed within the space. 8, 16. Okay, and again, when we look at this, we see fewer outliers. We see that mean, which is the X in the box, right on top of the median line. So again, confirming that we are becoming more symmetric with this distribution, just as we see with the box plots. And we can do the same thing for sale price. Oops. Okay. I might have just created another. Oh, yeah, there we go. Okay, so this was the original sale price box plot. Okay, we can create the box plot for the square root. I'll create these this last box plot, and then we'll come back and adjust any axes that we might need to. And then we'll create the box plot for the cube root of sale price. Right, we want to adjust these axes so that it's more evenly spread out in the plotting space. It's easier to look at. Okay, so with the square root transformation, we see the number of outliers decreasing, we see the mean and the median becoming closer together, and we see a more